Hello. Yeah, sure. Um, actually, let me formally start the class and I'll answer your question because it's a good thing. And I also like to get input from you guys to see what you're thinking. Okay. All right. I'm going to open this up in prayer and give you a sense of what we're going to cover today, and then make sure I include where computing comes into this. And so, dear Heavenly Father, Lord, thank you for the chance to be working with each of the students in this course, the bright minds. We're all excited that they're here at EPU. And I pray that you would help them as they're getting a chance to learn technical skills. And so in this course, get an introduction to what engineering and computing is all about. And Lord, help them in their spiritual formation, Lord, as they get a chance to be studying scripture, that they can store all those treasures in their heart and in their future, that they can understand the theological concepts in which we can be drawing applications of scripture in our day-to-day lives, and give them interesting and creative ways for faith integration. In Jesus' precious name, we pray. Amen. So let me go ahead and answer your question, but I'll give a little bit of context about like here, what I shared on the first day, what is the catalog description of what it is, where does computing fit into this? So we're doing an introduction to engineering and computing. And so students in the course get an overview of engineering and computing as a creative and responsive profession, and learn about the qualifications engineer and computer scientists have in the ways in which they study, think, work, create, design, and communicate. And so what we've been doing so far in our course is just running through this introduction about the engineering profession. So when you choose a textbook, you have to make a selection. And so they may or may not be doing exactly what you would hope to be covering in the course. And so I don't know if you're thinking that it seems like it's a little bit more engineering than computing. Is that your perspective? Yeah, it's perfectly fine. And so usually when I use a textbook, I really like to get it from their point of view. And it's like there's another person in the room and it's the author of the textbook, them telling their story of what they think this is all about. And so it does tend to be a little bit more engineering focused. And this is the good feedback that I want because it helps me to what I would supplement in the course if there needs to be more computer science or other types of things. But without that input, I'm just going to be going on the basis of what I think the textbook is really quite useful. So there's different types of computing. And what we do is we get into this area where we explore using some tools, Python, MATLAB, even a spreadsheet is something that we use, or forms of computing. And I've actually used Python for doing things in machine language and AI. And so there is some things that I could bring in a little bit more focused on that if there is a desire to do that. One of the other courses I teach is something called software engineering. So there can be this overlap between computing and engineering that you can be using an engineering perspective for architecting software and software systems. So that's a little bit of an answer in your question, but let me pause and let you respond and tell us what you think and what you're hoping for.
My degree is in computer information systems, minor in science.
Mhm. Yeah.
Experience engineering, so I was just a little nervous about that.
Well, let's talk to that. And so the proposal is, what I'm trying to do is have people think of something that they're interested in. I was focusing on an engineering perspective. You could just as easily, hello, welcome. Well, this is engineering 101, so.
Yeah, sorry.
No, no problem. Sorry for any confusion. So what I was trying to do was thinking that something that's a little bit more on the engineering side for the proposal, but it could easily be finessed to something more on the computer science or CIS perspective. What is your thoughts on, say, your areas of interest? And let me see if how many more fit into that category that you're a computer science or CIS individual? Okay, because this is the kind of information I need to know about my audience, because let me tell you, the difficulty is when I saw the enrollees, there were people that were computer science and engineers, people that were freshmen, people that were sophomore, people that were juniors, people that were seniors. So that's just a whole gambit. And so it's hard to figure out exactly how to tailor the course.
I was thinking cybersecurity or AI.
Mm-hmm.
but-
Yeah. Okay, that's fine. Well, remember, this is a introductory course, 101. So let me say just for the engineering side, but it applies equally for computer science and CIS. You're going to be doing some research. And so pick one of those topics and your proposal is I'd like to do some research in cybersecurity. I'm not saying that's the one you're going to do. And so maybe you have a couple of references of things that you intend to explore, what you hope to get out of doing that research. So you can be using this engineering mindset in something that is of interest to what you're trying to accomplish. So it literally is intent to try and be helping both engineers and computer scientists to let them see what an engineering perspective is. And engineering and computer science and departments are oftentimes commingled because there can be that connectivity. Computer engineering is another example where you see it start to converge. Anyone else have some thoughts on that or anything that you'd like to mention in terms of the context of what you see in the course? So I was trying to keep the proposal work generic so I could allow for that flexibility. And really the sky is the limit. One of the things I've been doing some research in is in machine learning and also neuromorphic computing, if you've ever heard of that. And so it's a way of how we can be doing computing the way that the brain works. And I think it's hugely fascinating, but there's a lot of things that are hugely fascinating. And so one of the things I've been doing is using Python and other tools to start to look at how you would have neurons and neural networks to see how it could play out in doing different procedures and different capabilities. No, no, this is just it's trying to, for me, it's trying to understand the human brain better. So one of the ways you can be doing that, bless you, is by doing modeling and analysis. And so if we can understand a convention, a design pattern, since you're probably familiar with that term, that's used in our brains, how can we start to figure that out? Because we can't get into our brains, once you do, it's most likely it's terminal. It's only in special cases when there's some pathology that they have to get in the brain, and then while they're there, they can be doing some probing and get some information. So that's in that sense, doing things with these tools can be a way of giving you some perspective. So feel free to in your proposal to truly embrace something that you're interested in, not something you think I would want to see, but something that you want to do research in. So I will say that there is going to be this second section where this will get into some engineering specifics, and it may not be that correlated with what you're wanting to get into, but work with me and let's see if we can start to make it, have you have a context. I'm literally trained as an electrical engineer, but I've gotten a lot into computer engineering and computer science, and I like both. And a lot of times I find that computer science can be a little bit more creative, but it depends on what framework you're thinking about. Because I've also done a lot of things in system engineering, which is very creative. Um, any other thoughts or comments on that, Fred? Okay, go ahead.
What about the ideas could include topics like the following sample idea parts?
Like on the project proposal, how you have that, like for the computer science people, like, can you give us examples of what we would potentially do there?
Well, I'll kind of leverage a little bit of what I was already talking about, just to start with that. And so machine learning, AI, there's just a lot of things that are being done in that area. And I'll try and talk a little bit more about this on Thursday if that's okay, because I can pull up some of these notebooks, things that I've been analyzing to how you can have a neural net of multiple layers and start to explore what you can do. Like there's various areas of a machine learning and deep learning that I think are quite interesting. And so like one of the things that's gotten a lot of traction recently is GPT, where you can be looking at what can be done with natural language processing. And it's just one bent of what you can be doing in machine learning and thinking about that. So maybe start writing about that. Another thing that I was exposed to is using machine learning methodology. You can be helping things in medicine. So say you're doing various types of images, looking for pathology, and when you have so much data, it can be very overwhelming for a physician or some kind of technician that's helping out. And so what they've started to do is to use machine learning to start to characterize what is normal and so what would be abnormal. And so they can, by having a large training set, they can get a better sense of what is the realm of possibility and how well can this be a diagnostic precursor for what a physician could be considering. So that would be another interesting area to do some research and to characterize.
And again, these are research papers, right? We're not trying to embed anything.
We're not trying to invent anything. You're trying to analyze things. What we talked about last week was to think like an engineer. There's an engineering mindset. Well, that's really shorthand. You could say engineering and computer science mindset. Okay, so I'm sorry if it seemed like I was going a little bit in one direction. Off the top of my head, those are a couple examples. Can you give me an area of computer science that you're interested in? Maybe I can try and
Just like app development.
okay. So so app development is such a broad topic. And so app development to do what? Maybe that would be part of your answer. And there's a faith integration component of what we're trying to do in our education here at APU. So if you wanted to be focusing on app development, so when I always think of app development, I think there's a front end and a back end that you need to be developing. And so your front end, most of the time is just an interface to relaying information back and forth from the back end of whatever kind of sense of the focus of the application is. And so software engineering starts to give some constraints and perspective of how you be thinking as an architect rather than just creating code. And so maybe thinking of a software engineering as an architect, how you would go about constructing this. What are design patterns? what are approaches that you could be using in one form or another. So those are just some observations I can make off the top of my head. Then it would, be getting a more specific into areas of apps. And so there are apps that are more quote engineering kind of centric. Like one of the things I've started to see on my cell phone is like literally there's an app now on my iPhone that you scan something and it'll tell you how wide it is and how high it is. It gives you this kind of specific metrics that I'm just amazed that that it's able to do that. Apparently it has a way of telling the distance, and from that distance, and it gets that angle, and from that angle, it can tell you how wide it is or how high it is. So that is app development, but it's also getting into, there's some physical requirements. There has to be a way of using a radar of some sort, or I think I'm not sure what mechanism it uses for that, where you can get this crossover between computer science and engineering. And a term I like to be using is a cyber physical environment. So any computing system that has that cyber physical element, there's the software, but there's a physical hardware and the sensors that you're trying to have it focus on. So maybe if you could think of a category or a capability that you're interested in, and then start to be thinking about how there can be this crossover between phenomenology, sensing, and what you're trying to do with this app. That would be a way how you're embracing some of the things in this crossover between the engineering and the computer science. Does that help?
Yeah.
Okay. Maybe I'll just take one more. Is there anyone else, if that didn't kind of scratch an itch for you?
Cybersecurity, so if I did cybersecurity, basically I'm going to find a subject of cybersecurity to run my people in that category of cybersecurity.
Well, let's consider cybersecurity, because cybersecurity is such an important issue on so many different ways. Writing code so that it's not making, there's no ways that it can be, data can be inappropriately exfiltrated in one form or another.
I want to be on the back end of it.
Okay.
The other person does the gist of it, and then I'm like, I come in after, I get hired on afterwards.
So doing forensics?
Hmm?
Doing forensics of an event that has actually happened?
Yeah.
Okay. What, there's like the prevention, and there's also the being like the detective on the prevention side. So ensuring that everything is up to date in terms of all of the patches, that the accesses are controlled, and verifying that.
Yeah.
And so what would be an engineering perspective that would start to be important in those engineering and computer science mindset for thinking about that? Is you have to be thinking of the big picture, higher level abstraction. What is it you're trying to accomplish? Then getting more specific into this area. So cybersecurity for what? For a database, or for commerce, or financials, or where does those things that there's maybe a slightly different set of.
FBI.
Okay. Well, one of the things I was exposed to mostly secondhand was with the FBI. And so one of the things they had for an Android, I know it's a front end, but not a back end, but the Android platform is they had something called Fort Knox. It was a way of hardening a handheld device so it could actually handle sensitive information on a mobile platform. They're also with the FBI, they're looking at various ways of making this information available across multiple platforms. And so the heart of that data is in the back end. But then you need to mediate, and so there needs to be access control of getting in and out of that information. With the FBI, one of the big criteria is you need to have their focus as a government organization is to uncover, find evidence, prosecute people that are breaking the law. And so everything has to be mediated with a warrant. And so there's multiple places that they have to keep coming back and getting that other agency check before they can make that next step of what they're going to do. So for you, in this construct, it would be partly an architecting perspective, and having drawings and illustrations would be important for you to be coming up with this architecture. I'm not talking like really detailed necessarily, but it's going to be hard to convey in just text what you're trying to say. And if you're doing literature review, you're going to be finding some of that helpful, but then having you create your own way of constructing that in a way that would make sense in terms of what would be a good cybersecurity way of dealing with these kinds of sensitive bits of data, PII, personal information that you're dealing with and giving the right individuals and not the wrong individuals access, and then coming up with observations and recommendations based on what you're finding. Does that help? Good, because I know last Tuesday I wasn't getting that everybody being excited at the end of the lecture, but a few people zoning out. So now I got a little bit of an idea what might have been going on. So any other thoughts or comments? On the flip side, we do have some engineers, and I don't want that to turn you off either, but all of the above, this can be a fun course, and I'm trying to make it that way for everybody, okay? So pausing for one more moment. Any other thoughts or comments?
I do just have a question, like on the project proposal, like you said, like to have an abstract,
Yeah.
like a summary. I'm just wondering like how long you want it, or like how in depth like you want us to go for that summary.
Well, let me answer it in maybe a general way, but after I finish my explanation, it may make more sense. What I'm trying to do is get you used to what it's like when you're out in the world where you're trying to get real funding. And so it has to be impactful. It has to have an excellent title. It has to have a very good first sentence. It has to have a first paragraph that is going to making someone say, I want to keep reading this because this is something that we really need. So it needs to be as long as it needs to be to have those characteristics. So if you want a general sense for a proposal, maybe 1 to 2 pages, something like that. That would be, but also having those characteristics that you want it to you guys, I think for some of you, especially if you're freshmen, you haven't had some of the writing courses. One of the courses that I've taught here, technical communication. And so it's not just writing well, getting your grammar and your vocabulary the way you would like to have it, but really thinking of your audience in mind. And so you could be thinking of, this is a proposal that you're writing to someone that you want to have them give you $10 million. And so guess what? If it's going to be that much money, you're going to write it really well. You're going to have somebody double check it. Well, we're not going to go that sophisticated, but we definitely want it to be, let's think about making this the real deal. This could also be, since you're writing on something you like, this could be a seed for something that's going to come later that you're going to continue to develop in your time at APU and do professionally. You guys mentioning things, app development, cybersecurity, whatever it might be. It's nice, and sometimes you can be doing it on multiple courses. You can take that idea and you start to see that here's these various elements that need to all come together for me to be able to accomplish this goal, to have this career, to have the expertise I want by the time I leave here. Plan it ahead. Remember, we talked about planning for an engineering career, and we talked about your degree plan and all these other things. Plan out what courses you want to be taking here, what you want to try and accomplish. Start to get on LinkedIn getting people that you're connecting to that are doing what you want to do 5 years from now, and start to connect with them. What should I do next? As you develop those relationships, having those mentors to help you, it all can be a useful thing. Does that help? Okay. All right, this is your course. So I have material that I would like to cover, but I also want to make sure that I'm hearing what folks are thinking as we go along. Okay, so we talked about an introduction to the engineering profession. So we had a chance to talk about that. We talked about preparing for an engineering career. And of course, as I mentioned, this textbook is geared a little bit more towards the engineering side, but it does have that flexibility. It can easily go in the direction of computer science and computer information systems as well. So let's think about that, the engineering design process, software engineering design process, whatever you want to be thinking about, it all comes up again and again. So the objectives, the chapter objectives is engineering design process, explain the basic steps that engineers follow to design something and to arrive at a solution to a problem. In the software engineering course that I teach, the first thing that you have to figure out is, what is a problem? Is it a problem that people want to have a solution for? It sounds simple, but it isn't always that straightforward. Additional design consideration, describe what is meant by sustainability and its role in design, explain the role of engineering economics, materials, and engineering design. If you're writing code, you don't want it to just last 6 months. It's got to last until you replace it, okay? So when you do software updates, you don't want it to break it. When you're designing something as an engineer, you want it to build, and what is it, the stresses and strains that it's going to have on it. You want it to continue to be operating properly and not collapse halfway through its life cycle. Teamwork, explain what is meant by a design team and describe the common traits of good teams. Explain how good teams manage conflicts. A good team is a diverse team. So each one of you has different skills, and you bring that together, and it makes for a very powerful ecosystem, a very powerful design team. So that's something that you would want. Project scheduling and the task chart. If someone's going to give you $10 million, they're going to want to know, how long is it going to take and what are they going to get at the end? So that's where stuff like this comes in. You have to do the programmatics. And so describe the process that engineering managers use to ensure that a project is completed on time and within the allocated budget. That's just gold. If you can get it on time and on budget, that's exactly what they want. Engineering standards and code, describe why we need standards and codes and give examples of standards and codes organizations in the United States and abroad. So if we're not building to the same software standards or the same hardware standards, IEEE standards, MIL standards, whatever, you're going to run into problems. And so this is make sure we're all going in the same direction. Water and air standards in the United States. So this is getting into an example, maybe a little bit more on the taking care of our world perspective. Describe the drinking water, indoor air, and outdoor air sources of pollutants that give examples of water and air quality standards in the United States. So there are some specific things, maybe that won't be one we'll focus on based on what I've been hearing for the folks that what you're interested in, but it's here in our textbook and you can take advantage of that. So there is an engineering design process, and I would argue that equally applies to engineering as well as computer science and CIS related efforts. And this is just over several pages what that would look like. First of all, you recognize the need for a product or service. The need for a product or service could come from you, your company, or clients. And so what is a problem? What is a need? And then you have to get specific about, well, we have to characterize that in a requirement sense so that you can then figure out how you're going to have, what are the criteria that your design is going to fulfill. You want to come up with a problem definition understanding, make sure you understand the problem and the problem is well defined. So you can be talking with clients or stakeholders and say, does this capture what you think the problem is? And so if it's a cybersecurity issue, tell me about the three worst breaches you've ever heard of or ever experienced. And what do you think was the problem that they found? There wasn't enough checks and balances for making sure that patches were applied. Or maybe that the access rights were not checked often enough. What happens if someone loses their credentials and somebody finds it? Are they able to just log in? Or two-form authentication, that's a big thing that's starting to come up now. Research and preparation, collect useful information as much as you can. You're going to be doing some of that in this course. You're going to have your idea for a project, and then you want to be talking about what's going to be required to make that happen. Conceptualization, you want to generate ideas or concepts that would offer reasonable solutions to your problem. And so how are you going to capture that idea? Maybe starting with words or a graphic of some sort. There are more formalized ways of doing that. Maybe a use case diagram, for example, or just simply a bubble chart where you're showing the relationships between entities. You want to be evaluating alternatives and do an analysis of alternatives. When a design is narrowed down to a few workable concepts, evaluate those concepts as needed before the detailed design is pursued. So you have three options. Which one are you going to go with? So what are the pros and cons for each one? Then you have a synthesis. At this point, you begin to consider the details. Now that you've got these ones that you've spent enough time to flesh out, you can be thinking about those perspectives. Evaluation, analyze a problem in more detail. Now you can be using these proposed solutions and have some test criteria and evaluation to see how well they do. You do a performance shoot off, if you will. Optimization is based on some particular criteria such as cost, strength, size, weight, reliability, noise, or performance. So you checked them out, you're kind of leaning towards this one, and you find out there's a little bit more than it needs in terms of capabilities. Is there another software component there, or is the material the right thing for an engineering build of material, something like that. And finally, presentation, you want to communicate your solution to your client, prepare for an oral or written report. And so towards the end of the course, we'll have that opportunity that people can be sharing what you've developed. And so that's what we have there. I've been including these videos. Last week it didn't work, so we'll see if this one does. I think things look fine, so I'll try and click on it, see what happens here.
Process. This process involves a series of steps to guide them in developing a solution. Each piece of technology on the space station and in your home or classroom involves engineering. But what exactly do engineers do? Well, they use science, math, and their own ingenuity to create solutions to technical problems. Examples of technical problems could be developing more efficient light bulbs or vehicles, lighter sneakers or aircraft, an orbiting space station, and transporting humans to Mars.
Here's one example of what the process looks like.
Step 1, identify the problem. Step 2, identify resources and constraints. Step 3, research. Step 4, develop solutions. Step 5, select the best solution. Step 6, build the solution. Step 7, test and evaluate the solution. Step 8, record and present the results. And step 9, improve the solution.
Sound familiar?
Take a look at the space that we are currently living and working in. This space is filled with things that have been engineered using the engineering design process. Some of these items are low-tech, like packaging, storage compartments, and fasteners. And some of these items are high-tech, like computers, cameras, and science experiments.
A great example of an engineering solution to something you might be surprised is a problem in microgravity, how do we drink fluids? How do we keep them contained and how do we get them in our mouth without making a mess everywhere? Here's our standard drinking pouch. I've got some grape drink in here and a very nicely designed straw. It's just perfect for living in space. If we didn't have this straw, start to see some fluid coming out there. I don't want to make too big of a mess, so I'm only going to demonstrate what would happen for a second if we didn't have our straw here. And this would come right off. It's getting on me right now. So let me drink this up. But as you can see, we have a clasp here, very nicely designed. It pinches the straw at this point here, and that keeps more fluid from coming up the straw. And that way, you want to drink something, you just open it up when you need to drink. You have to remember to close it again before you pull it out of your mouth. Otherwise, you're gonna get more fluid coming out.
Hey, Tom, you're floating. I think that's not convenient for working, no?
That's true. Got a little bit of a problem in that if I do any work with my hands, I'm gonna be pushed away from where I'm working. And if I have to find a place to put my feet, which I really want to do in order to get any work done, sometimes I can't find a place to put my feet. Still working on it. So I got a problem.
Based on astronauts' feedback and data, we developed these rounded hand and foot rails so that you can stay in one place comfortably for short periods of time. To maximize comfort, we also have these socks that are padded with rubber on top and bottom. For longer periods of time in one workspace, we engineered these foot restraints with cloth straps. You can slip right in and adjust them.
Thanks for exploring the engineering design process with us.
I'm going to send it back to us so you can solve your own engineering problems using this process.
See you again soon.
Okay. Well, that's just giving one example. It's a little bit more engineering specific, and I would argue a little bit more of a specific area of engineering, maybe mechanical engineering, that they were focusing on. But some other observations I can make about the ISS. I don't know if you noticed how busy everything was. It was just every square inch was covered with wires and contraptions and what sort or another. The ISS has been around for a long time, and it's no longer can use the conduits and stuff that it was there. So they literally are just on top of one another, trying to kludge it together to keep it functioning. They didn't really get into the computer side of it to maintain the orbit of a satellite. There takes a lot of software, a lot of analytics that need to be done. So it's not just a hardware problem that needs to be thought through in that kind of a perspective. Anybody have a thoughts on that video that help or give you some insight? Some of you, I think you're excited about NASA, and I think that's wonderful. Like I said, the neat thing about NASA is they make a lot of information readily available like this, which is helpful to give some perspective on things for this course. I'll try, I have like some other stuff that are a little bit more software centric. I'll see if I can start to bring those things up as well. So, but just humor me that I don't have anything on that right now. So general engineering process, you saw what they had in the video, kind of fit what we had in this layout of this flow, maybe a little bit different, but in general, the same principles. We have this general process of you have initial design, perform analysis, evaluate the results. Can the design be improved? And if so, then you modify it. This is true of hardware and software. I always talk about in the software side of coming up with an MVP, a minimal viable product. And then you can start to refine it, maybe add on more capability. But it's always a good idea to go from working capability to a working capability. And so you just do a little bit of development at a time. That's true for hardware as well. One of the courses I teach is computer architecture, so we use Arduino units. And the same thing, you want to get some part of that circuit that's interfacing with that hardware, that Arduino computer unit. So it works, then you figure it out, okay, now I'm going to add a little bit more without breaking that, just like you write one software method before you move on to something else and get it functioning. So there is a variety of other things that they cover in the textbook. And so for civil engineers, you're more focused on the roads. Some of you may have had to drive here to school this morning. I had to drive here. It's a real pain. It's a long drive for me. And I could wish that there were some more civil engineers that were dealing with all of the congestion on the highways, but that's just another thing. But what they're doing is they're looking at building buildings, bridges, tunnels, and airports. I don't know if you noticed, but I've had to drive down to San Diego a lot lately with my wife to visit my mother-in-law. And so when you're on an asphalt road versus a concrete road, you can actually feel it a lot. It has different. So the concrete tends to last longer. The asphalt is smoother. But what they have to do with the concrete is they have to put grooves in it to try and make sure that you have this good connection with the road. Those are just examples of what are the criteria you're trying to prevent skidding. It's meant to be all weather type of capabilities. And so roads and highways and dams, all those things are there. Mass transit systems. Some of the times I actually come out here using public transportation. There's something called Commuter Express. It takes me to Union Station, and then I can take the Gold Line all the way to the end here to Azusa. And so for my trek, that was what it would have to be. So what are ways of how to reduce congestion? We're coming up to the Olympics, and I'm old enough that I was around during the last time they had the Olympics here in Southern California, and they were trying to optimize mass transit in various ways to be moving the huge masses of people that were going to be in this area. Water supply systems, all of this falls into the same kind of area. So similar process, recognize the needs for the building, number one. Number two, define the usage of the building. So what exactly you're trying to do the project planning. What do you think is going to be the cost? What are the drivers? What are the things that have to be going on? There's regulation. Come up with a schematic design of the phase, and so come up with the blueprints. Get into the design development phase. This is where you get into more details of how things are going to be worked. Then you get into the construction documents. It's not just a design, but the manufacturing process, all of that has to come together. And finally, the construction administration phases. You maintain management, operations, and making sure that it works through the whole life cycle of what's required. So some similar, few different slight ways of thinking about it. We had a general engineering process that's also useful in software areas too. And we can see over 3 pages, there's some similar things that have to take place. Okay. Well, let's think of a quiz here. The blank engineer provides all the design details for structural components. What do you guys think it is? What was that? Civil? Well, it's one of those. Structural. The structural engineer provides all the design details for structural components, including the foundation, beams, and columns, interiors and exterior walls, connectors, connections, additional support for openings such as windows, doors, roofs, supports, floor supports, canopies, and so on. So I'll just go back to this. Here we have all these different types of engineers that for forming a team that you're drawing upon to be helping out with a design. And so this is more in a building kind of a scenario that we're thinking about here, okay? You know, they don't talk about the software elements, some of the CAD drawing software. There's what is happening now, model-based system engineering is starting to take hold of a lot of things where you can be doing a lot of things through without actually building something yet. You can delay that a little bit. It's a lot easier to run an analysis through various software tools than it is to actually be bending metal. And so that's something that can come into place and be a helpful thing. What about other consideration? Sustainability. You want it to last a long time. The Voyager spacecraft going outside of our solar system and still going, is a good design. So for sustainability, there's no universal definition. A generally accepted definition is design and development that meets the needs of the present without compromising the ability of the future generation to meet their own needs. So I'm maybe confusing things with lifetime and having a robust design versus sustainability, that you're designing as such that you're not impacting the environment in a negative way, trying to find the right type of constituent elements and construction methods that are good for the environment. An ethical guideline for building a sustainability, just and peaceful global society in the 21st century. These are just some things to be thinking about. I'm just going to skip over this, but we want to be good stewards of the things that the Lord provides us. That's maybe a good thing to consider. So this is like an addendum for thinking about design, for sustainability. What is a purpose or goal? What is an inventory analysis, impact assessment, and improvement? So you can have an independent sense or an independent team feeding into the overall construct, that they have expertise that would be in complement to, say, for this situation, we were talking about civil, mechanical, structural, and electrical. Now we have another set of skills that are trying to be thinking about sustainability. We don't want to have something that works once and then you dramatically pollute the environment. Then you have a huge cleanup mess that you have to deal with. And so that's something that is worth not making happen. Engineering economics, guess what? If you're not funded, it's not going to happen. So economics factors always play important roles in engineering design decision-making. Products that are too expensive cannot be sold at a price that consumers can afford and still be profitable to the company. So you have to have a return on investment. Products must be designed to provide services not only to make our lives better, but also to make profits for the manufacturers. It has to be a win-win situation. Both parties have to be in a winning scenario. There are a number of factors that engineers consider when selecting a material for a specific application. And so these are just get into things. We'll get into this in the second part of our course. Electrical resistivity, electrical engineering related thing, density, say a mechanical related thing, modus of elasticity. So this is how the material can flex, its ability, how much stress it can sustain before it has strain, modulus or rigidity. Some things need to be quite rigid, and so they have like these certain types of structures that are going to make them to be able to handle highly stressful situations, whether it's a wind or other things. Tensile strength, compression strength, and so how much it can be pulled apart and not break, how much it can be compressed and not deform. Those are just examples of that. Modulus of resilience, modulus of toughness, strength to weight ratio, thermal expansion, thermal conductivity, and heat capacity. So I'll just deal with the strength to weight ratio, since a lot of my industry background has been in aerospace. And so satellites, they cost a lot of money to launch. And so if you found some material that was lightweight, that still had the same, but had a better strength to weight ratio, that's going to be a plus. You could then use that saved weight to add more electronics or something like that. You're gonna think about viscosity, vapor pressure, bulk modulus of compressibility are additional fluid properties that engineers consider in design. So maybe you have some type of fluid that is used for you can think like brakes. It's using fluid to have the braking action. And so the fluids are actually used as part of the process to enable the action that you want. Patents, trademarks, and copyrights. Patent is when you have something that you created that no one else has, and you formalize, submit it to the United States or other government as an invention, and so it goes through an approval process, and then you have rights, copyright rights that people, if they're going to be using your patented idea, they have to pay you for that. Trademarks and service marks, it excludes others from using the same or similar mark or term or phraseology. And so with a patent, you get this copyright as a form of protection by the laws to the authors of the original works of authorship. So let's see if we can just have a conversation here. We can broaden this out. This is a discuss the importance of mechanical properties when selecting materials. Anybody wants to postulate a more software-centric type of topic that would be important when we're thinking about a design? How would we do something in cybersecurity that you need to be evaluating? Or maybe you're still looking at it and you don't know the answer to that. So, well, maybe I'll just start with this to beginning of here. And so we're talking about this list of things, and probably most of you, a lot of these terms you haven't heard of. I've taken a couple of physics related courses and have got exposed to some of these. But let's say we're going to design something and have you guys help me. What would you like to design? A bicycle, a car, a building, a cell phone? You mentioned mobile apps. You have to build it for something. What would you like to do?
But not chat.
Yeah. Okay. So I'll start with that, since I did take recently some machine learning courses, and there are some components, machine learning components that are needed, and then ChatGPT is just a layer above that. And so you needed to have a lot of association engines that are able to detect the languages and the syntax of the words that are coming out and start to make projections of what it is that they're talking about. What would they want to so first of all, you have to understand what the question is. And then what ChatGPT and related things do is they're looking at all of the internet, all of the resources, and you're putting that question, they're slowly narrowing the window of these are the things that I have that I can answer that. And so you have this metadata of sources that are going to be answering that question that ChatGPT wants or something like that. And then it has to put it together into a logical prose. And so then this is where it starts to be not totally accurate, because it has to make it sound right. And so it may overemphasize something, maybe even misrepresent the facts. Like if you were to put in somebody's name, and if there's enough descriptive information, they'll find a half a dozen sources and they'll integrate that all together into a paragraph or two of like this really impressive expose of what this person does. So those are the things that are needed. But guess what? That algorithm for putting it all together is not totally accurate. So that would be something, and quote, selecting the materials for a software development is something that you would have to be thinking about, that you would want to improve. How well are we interpreting the question? I've been able to stump GPT. And so it just has, I'm sorry, I have no idea what you're talking about or something like that. Maybe I typed it in funny, but whatever. But I've been talking a lot there. Let me give, how about some of your thoughts, either in a computer area or engineering area? What do you think some of the properties that you would be dealing with, how important that is before you make a decision of you're going to go with one direction or another? We're thinking of materials, say for a mechanical related thing. So those are their engineers. What kind of engineering are you finding yourself interested? I think maybe I heard a little bit aerospace, but mechanical. Okay. So why don't you try taking this, giving some of your thoughts about that. You may or may not have been exposed to some of these ideas as of yet. If any of them sounds familiar to you, and if not, maybe just think you don't even have to use those terms, but what do you think would be say if you wanted to, well, like we have a bunch of trees in our around our home, and we have to keep them trimmed. And it'd be really nice if I could get some shears that stayed sharp, better than the ones that we have. What do you think that would mean in terms of the materials and the mechanical properties that I would want to have? Or you come up with your own idea. That just give you something to seed your.
Like, you want the shears that can stay sharp longer?
Yeah.
Well, I guess looking at the material, there are a couple of, obviously, I would say the sharpest is diamond, but.
Yeah.
Obsidian is also pretty sharp.
Mm-hmm.
One of the sharp- It's the- Well, how do you, I guess, steel
Yeah, well, let me just break that down like what you're saying. So I appreciate it. I mentioned like sharp and you mentioned specific materials, which is really great. And so even like, what does it mean to be sharp, sharper? That's something that's not really stated in engineering terms. So you want to be more precise about the characteristics of what you would want with that material and the way that you sharpen it or the way that you temper that material to help out. But what you're saying is exactly right. You know, you're thinking, well, let's start with the materials. That's what they're talking about here. And then what are some things that we can be doing to those materials? And then you started to do the analysis of what would be practical for this application. That's another thing that you need to be considering. The cost, we mentioned that. Maybe it would be a great material, but its manufacturing would be extremely expensive. Are you going to line the edge of these shears with this other material because it's easier in one way or another to do it that way? So, any other thoughts? Okay, so we're just starting to see some perspective of what it means to begin to think in this engineering and computing sense, and we'll leave it at that. So we have to work together as teams. Some of the courses that you'll be doing here at APU, at least one, your capstone project you'll be doing as a team. And so I teach one for computer science and CIS majors in the spring, but the computer engineering course is the one that they take in the fall. So for teamwork, a team is a group of individuals with complementary expertise, problem-solving skills, and talent who work together to solve a problem or achieve a common goal. Employers look for individuals who not only have a good grasp of engineering fundamentals, but can also work well with others in a team environment. So that's another one of those soft skills that it's going to serve you well, and think about having that in your expose of things that you can be doing. So a successful team has these components. The project that is assigned to the team must have clear and realistic goals. The team should be made up of individuals with complementary experience, problem-solving skills, background, and talent. The team must have a good leader. Over time, some of you may find that you have leadership skills, or maybe you say, I can recognize those skills. Either I don't have them or I don't care to be in that position, but either way, it's good to figure out. Team leadership and the environment in which discussions take place should promote openness, respect, and honesty. And that the team goals and needs should come before individual goals and needs. So to have a good team, you have to have good conflict resolution, to see if there's miscommunication, personality differences, the way events and actions are interpreted by a member of the team. All those are stuff that you want to be working through. Managing conflicts is an important part of a team dynamic. And in managing conflict, it's important to recognize there are 3 types of people: accommodating, compromising, and collaborative. Maybe you might find yourself fitting into one of those categories, and just think about that. What do you think would fill in this? The blank is someone who is experienced and confident. I didn't cheat and look ahead, so I don't know either. So it said organizer. And so the organizer is someone who is experienced and confident. Person is trusted by members of the team and serves as a coordinator for the entire project. So maybe in this sense, you could be seeing an organizer as one that's been in the trenches already. And so they're helping other folks, and maybe they're a senior member. That's a nice thing to have on a team. So keep that in mind. Project scheduling and task management. This is important. Having a schedule. Project scheduling is a process that ensures managers use to ensure that a project is completed on time within the allocated budget. If you can do that, man, you're going to be really sought after. A well-planned schedule can also improve the efficiency of the operations and eliminate redundancy in task assignments. Another great thing, you're reducing cost. And this just gives you an idea, one way of how you could be thinking about what a schedule would look like. All of these things, these are the precursors. Then you can get into some things that you can do in parallel. Finally, you do some integration and bring it all together over here, like, what is it? A little bit more over than a year. You can see that laid out. Standards and codes, why do we need them? They're developed over years by various organizations for product safety, reliability and services, uniformity on part and components. And so you have these standards and codes, and you want everybody to abide by them. That's just as equally important. Standards allow for easy ways to communicate the size of a product. For example, if you have a global standard for shirts and shoes, then cross-reference tables would not be necessary. If the shoe size here and in Europe were the same, I believe they're a little bit different if I recall. And so that's just one example of what that would be. So here are just some examples of standards and code organizations. ANSI, American National Standard Institute, ASTM, American Society of Testing and Materials, NFPA, the National Fire Protection Association. You probably have heard this, UL. Some of your electrical outlets, UL approved, underwriters, laboratories. ISO, International Organizations for Standardization, CC standards, the letter. So this is a French standard for, I'm not going to try and say that, Conforti, European, BSI, British Standard Union, CSBTS, China State Bureau of Quality and Technical Supervision, DIN, German's Deutsche Institute for Normen. So the International Society for Standards was first established in, anybody taking a guess? Maybe you gathered into the textbook and saw that. If not, 1947. Just to give you one little tip for that. Well, I'm just gonna skip through this fairly quickly because we've had a lot of good discussion in the beginning. This last section was just talking about water and air standards in the United States, how we want to be designing for sustainability. And so these are just things that you can take advantage on your own to be looking through. We want to be good stewards of our environment, everything the Lord has provided for us. And these are just things that are here for us to consider. Okay, well, that's all I'm going to cover in the lecture. Once again, I really appreciate the participation today. Please keep it up. I want to hear from you. And go ahead.
Do you have like an example of the project, how you want it to be done? Like, is there a format or?
For the proposal, what I was envisioning is that it's mostly going to be a narrative, having an abstract and an introduction of what it is that you're going to be focusing on. And so, when I was building the course over the summer, I was just starting to give some ideas, but right now it is kind of engineering centric in terms of the ideas that I was formulating. So having an abstract, what are the fundamentals that you're going to be exploring? So this is more engineering centric. What type of computational tools that you were going to be leveraging? What is the intended results? And so for your project proposal, having 4 or 5 paragraphs that capture those types of things. So the goal is to create a summary of what you plan to do. That's kind of a sense of what I have. I could be more prescriptive, but I was trying to leave it a little bit open-ended for you all to. There was a lot of things that came up today that you can end up personalizing it as you would like.
And what we pick, is that just for this assignment, or is this gonna be leading on to building off of other stuff?
It's going to be, that's your proposal, and so that's your midterm and your final is going to be related to that.
So pick something like,
Yeah. So if it's cybersecurity or mechanical engineering, something or other, or app development, you're going to be building some new app for iOS or something like that, for a handheld or something like that. And I would like to see if maybe you could make it cyber physical, so it's not just an app, but it's also having to do something with the phone. Like maybe like it's an exercise monitoring thing, like my wife and I, we just went on vacation. And so it was recording all of the steps we took. And so you could see all of that information. If you have a watch, you can get your heartbeat. And so some more biometrics that you can be using. How can you use that cyber physical information that you're receiving from one source or another to augment what you're trying to do with this app? I would recommend you to try and look at that, because that way you're going to be embracing some additional things in what we're trying to cover in this course. Does that make sense? Okay.
So once we pick an item for the proposal, we cannot change it to the mention of the final, it should be consistent. Like, what if I say, oh, I'm gonna do this, and then later on I realize that wasn't really what I should have done? Or you think that the proposal idea that I think isn't that big, is that gonna affect my point?
Well, looking at what I do, I'll give you my grading philosophy is you can submit more than once.
Okay.
So if you wanted to submit and maybe you wanted to revise that, or maybe I give a little bit of feedback, I'd like more details. And the incentives, if you do more details, you'll get more points. It could be something like that. But no one can accurately predict what's going to come as an outcome. You try to say that's why it's a proposal. And sometimes a proposal is saying, well, I found a way that really doesn't work. But what we have is a little bit of time. So that maybe in the midterm, you start to make a little bit of a vector check one direction or another. And so this was my original intent and show that trajectory of, as I've done some more research, that you found this, and so you've modified it some. So it's trying, that's part of the engineering and computing process that naturally happens. Software development, you write something and you find, oh my goodness, I was going to be using these tools and they're not supported, they, we have to use some different software modules or something like that, or the way it was conceiving. It intuitively, it sounds like a straightforward concept, but when you get into the implementation, I need to refactor it in one way or another. That's all fine. That's exactly what the engineering / computing process is all about. Okay? So don't worry about that, but we are working together, and it is a journey. And sometimes the ebb and flow of that journey is really what engineering and computing is all about. Okay?
And you really want this done by Thursday night,
Yeah.
okay?
Having a deadline is a useful thing to help you guys think of what you want to focus on. And we'll go from there. All right. Well, thank you for a good conversation today. I'll go and end it for today. Thank you.